going to be a power through kind of situation. Sort of, not really. 2 athletes compete in a 2-event competition. Shot put in the long jump. Chris threw the shot put 63 feet and Ryan threw it 66 feet. Chris jumped 27 feet 3 inches in the long jump and Ryan jumped 27 feet. Is Chris or Ryan the better athlete?
So we're going to have to do something.
I was going to say, this isn't just an answer the question. This is like a do some math.
Better in different events.
Let's put in numbers and see what we get.
63 feet.
Okay, let's.
So Ryan is 3 feet better in the shot put, and Chris is only 3 inches better.
That doesn't mean anything, Nathan.
I think Ryan's the
All right, so we're looking at which athlete did better overall compared to his peers. We are going to use standard deviation to show how far a value is from the mean. And expressing values in terms of standard deviation standardizes the values. I'm sure that just logically makes sense, but you know. All right, so we're going to have a normal curve. Sort of. We're going to look up to 3 standard deviations away. So, now some information that should have been given to you. The mean for shot put was 60 feet with a standard deviation of 3 feet. The long jump was 26 feet. I feel like that's really far.
For a long jump. That's absurd. Like, holy wait.
I mean,
how long is a bus? Like an average school bus?
A bus
26
is...
feet, that's crazy. That's not, that can't be.
That's like the length of my classroom.
Yes.
That's excessive. There's no way.
It is.
I don't know. We're just gonna roll with it.
I've seen it.
With a standard deviation of 6 inches or a half of a foot.
So you said this is given to us, or?
This would have been given, yeah. I don't know why I didn't just type it in there, but
yeah, I was wondering what the other information was that we were gonna base everything off of.
I just thought we were going to solve for it.
Yeah, me too. And I was wondering how we were gonna do that. It's like,
Wait. What time's your practice?
3:30 to 5:30.
Why is
Are
he
you join them
He's
or
making
something?
us do practice at 8 o'clock.
Who?
Career for basketball.
It's probably because there was a typo in the email. I'm pretty sure that said middle school was practicing 5:30 to 7:30, but I'm like 95% sure they're practicing 3:30 to 5:30 also. So he probably saw that and assumed. I don't know.
Yeah, because he was like, well, what do y'all want to do it till 9:30? I was like, no, 9. If we're going to do it at 8 o'clock, we're doing it till like an hour. It's like, I need my sleep.
I like sleep. I need coffee.
All right, so remember the formula for z score is z is equal to y minus y bar over s. So we're going to do this for Chris and then for Ryan, for shot put, and for the long jump. So for Chris, for shot put, z is equal to, his value was 63 minus the mean of 60 divided by 3. So that's what?
1.
So this is going to be 1 standard deviation above the mean. Then Ryan's shot put, he was 66 feet, so 66 minus 60 over 3. So that's going to be 2 standard deviations above the mean. And then for the long jump, Chris was 27 feet 3 inches. So what is that going to be in feet?
27.25.
27.25 feet. So 20. Oops. Z equals 27.25 minus 26 over 0.5. And what is that?
If it was on, I hate 2.5.
2.5 standard deviations above the mean. And then Ryan for a long jump was 27 minus 26 over 0.5.
Which is 2.
So 2 standard deviations above the mean. So who's the better athlete?
Ryan.
Why?
Because he has more standard deviation
Yes.
above the mean.
Yep. Ryan is the better athlete.
Did you know?
Yes, I have my money on Ryan from the
He has his mom.
Who are you betting on Ryan?
Yeah, I did.
We can't bet here, Nathan. That's illegal. We're not allowed to bet in this school.
You can make
Please
a
don't.
good bet. I mean, you can make
I
a
can't.
good bet off of statistical analysis.
Please stop using big words. I'm not here for this. God would you do that?
That's a big word, John. We're scared of big
Ryan
words.
trumps.
It's actually Donald Trump.
I was thinking that.
I was looking at the second page and somehow my eyes registered the word punched and now I'm looking for that word and it's not there. I'm just a
Same.
little disappointed.
Just a little bit.
All right. A statistics class took a 40-point quiz. Results show a mean score of 30, median of 32, IQR of 8, standard deviation of 6, min of 12, Q1 of 27. And I guess there's no Q3. No, it didn't need that. Okay. Suppose your score is a 35. So, originally is going to go in the top box of all of these, so I'm just going to go ahead and write it in. And then the values that it told us. So, we got a 35, mean was 30, median was 32, IQR of 8, standard deviation of 6, min was 12, and a Q1 of 27. You can write that in the top of all.
There's no Q3.
Just don't need it.
I don't like that though. It's just weird.
I mean, technically you know what Q3 is.
Yes.
Is that
What's your IQR?
IQR is 8.
So what's your Q3?
It's more like
no, not
35.
Okay.
Yeah.
So you do know your Q3. We just don't need it. Unless you want to make an extra work for yourself. All right. So, we want to know what happens to each of the statistics if I decide to weight the quiz as 50 points and add 10 points to every score. So instead of grading it out of 40, I grade it out of 50. So basically, I'm taking the score and I'm adding 10 to it. So what is that going to make your score?
45.
Okay. What about the mean?
40.
Okay. Median?
42.
IQR?
18. I knew we were gonna get to it.
We can't just add that.
Couldn't be that easy.
Trick
It couldn't be
question.
that easy.
You don't add to the IQR because I'm changing everything by simply adding 10. So if I add 10 to the
IQR is
Q1
the same thing.
and I add 10 to Q3, IQR is still 8.
This is tricky.
What about standard deviation?
one would assume that it stays the same.
It does stay the same. How about min?
22.
22. And Q1?
Wait,
7.
77. I was just looking at 29.
All right.
Yeah, okay.
One of those people kind of failed this test.
80 points.
Just a little.
Just a little. That's why they curved it. What happens to each of the statistics if I decide to weight the quiz as 80 points and double each score?
So y.
Bigger number.
So y times 2. So your score becomes
70.
mean,
Let's just go with
60.
median,
64.
okay, IQR,
Wait, no,
16.
I was working soon. So we're gonna
16, okay. So when we're multiplying, we do multiply the IQR because that is going to change, okay. And if you're unsure, you can always find your Q1 and Q3 and then do it. And a lot of people don't think to do that. How about standard deviation? 12. What about min
24.
and Q1?
that guy still failed it.
Well, it's 70 out of 80.
What?
No, the guy who got 12.
Oh. Oh. Yeah, that guy. Yeah, he did really bad.
Would have done better on the.
What if it was a girl? Are you assuming their gender?
No, I'm just using that guy
Hey, he
as
was
a
doing
filler.
it in favor of you guys, actually. So.
That makes them. You're still dogging on the other gender.
All right. What happens to each of the statistics if I decide to weight the quiz as 100 points and double each score and add 20?
Calm down. Calm down.
you
So
gonna
is
give us
it
extra
2
credit?
times plus 20?
So 2y plus 20. So your score is
90.
90.
Okay, that's a lot better.
Mean.
80.
Median.
84.
IQR.
Weight. 16.
16. Okay, because we do the multiplication, but we don't do the adding part. Standard deviation.
12.
Min.
44.
And Q1.
74.
So that guy still failed.
Yes.
That guy did
Stop
not.
saying
Is
that
there's
guy.
or human.
Guy is a general term.
Exactly.
Is it like, hey guys?
Have you ever watched Survivor? Well,
Not
he doesn't do it
anymore.
anymore. But I don't watch the new seasons, so.
They're getting ready to start. They're going to be 90-minute episodes this fall.
Goodness. That's crazy.
Every year I start out watching it, and then something happens like the first week, and I'm like, nope, not anymore. And then I'll watch the final episode just because I want to know what happened. Because I'm a curious George.
Who won?
If you're getting 12 points on the 40-point quiz in statistics class, then should you really be taking statistics?
Probably not.
That's a whole 30%.
So many emails.
That's
All right.
gonna be
So
on
in
the
summary, adding the same number to every value changes the center and individual values talking about the mean and median but not spread, so meaning IQR and standard deviation. So when it says adding the same number to every value, that just means if we're gonna regrade the quizzes out of 80 instead of 60, we added 20 to everything. But that doesn't mean we're actually adding it to the. It's a little confusing how it's worded.
I'm just gonna take your word for it.
Multiplying every value by the same number changes the center and individual values mean and median and it changes the spread meaning IQR and standard deviation.
Are you in this class?
It sounded
Nothing to do with
really
each other.
judgmental.
What?
It sounded really
It
judgmental.
definitely was.
You're not in the class.
I know when I'm sitting.
Well, she basically is.
Yeah, exactly.
Wait.
She hears everything.
She could take the exam at the end of the year.
Yeah,
That's a great idea.
won't affect her if she fails it, so.
Just see what happens.
Hey, who said I was gonna fail it?
Technically, it won't affect y'all if you fail it either, but
Yeah, it'll just determine whether or not you're gonna have to take some
Take
more classes.
morale or something.
all right, Martha.
Ew. Martha Speed?
Hated that show. Martha scored an 80 on a physics test where the mean was 75 and the standard deviation was 5. Bob scored 83 on a chemistry test where the mean was 73 and the standard deviation was 12. Who scored the highest relative to the rest of his or her class? Show your work and defend your answer.
I say Martha.
All right, we're gonna draw
Ooh,
2 curves.
I love drawing, even though I'm bad at it.
On math, I'm totally math drawing.
When the kids used to do their senior speeches every year at graduation, they would be like, "Thank you, Mr. Cass, for teaching us that every math problem should have a picture with it."
I would not thank him for that.
All right. This one's gonna be Martha. So, mean of 75.
Name the graphs.
Oh,
Name the people.
you ruined my fun.
No, that graph is Martha.
It has a meaning.
She got an 80, which also happens to be 1 standard deviation away. No, it's mind blowing. This is Bob.
Oh, I thought that said.
That's so weird.
You never met a Bob in high school?
You've never met a Bob in high school?
No, they just spawn at 45.
That is so true.
Well, because
You hear him?
Bob isn't typically the given name.
It's usually like
That was
Bobby
Robert.
or Robert.
Yeah.
Has
But I've
anybody
never
called
actually
Mr.
never
Law
met a
Rob?
Robert as a kid.
I
don't know.
Have you ever heard someone call him?
I've never called him anything other than Mr. Law, so
Yeah. Yeah.
couldn't tell you.
Hey, Robert.
All right.
Mr. Bob.
Mean was 73, standard deviation was 12, so that means that 1 standard deviation away is 85, but he scored an 83, so I'm going to just note a little 83 on there. Very tiny, apparently. So, how would I find the Z for Martha?
Oh,
So you
easy.
do 80 minus 75.
Over 5.
Which is
1.
1. And for Bob?
Easy, because it's like 73. Wait, wrong. 85.
No.
83 minus
83.
73 over 12,
I was getting there, guys.
which is 5 over
Which
6.
is? Or
Less than 1.
as a decimal?
Like
Um,
0.83 repeating.
Yes.
Yeah.
All right, so who did better against their class?
Not Bob.
I told you it was Martha.
Martha.
Martha!
Good job, Martha.
So Martha did better relative to her class. Her score was 1 standard deviation above the mean. But Bob's score was only 0.83 standard deviations above the mean for his class.
Like RC scores on the next quiz.
Can we do that for extra credit?
What?
How are you gonna do it for extra credit if what's the scores yet?
Well, we do it afterward and it gets on the next thing. I mean, it may sound complicated. I mean,
It
think about
does.
it, it's
It
really
really
not.
does.
On to Angus steers.
Is that like,
It's like moose burgers, but for actual cows. I've met an Agnes.
Doesn't sound like it was a good experience.
An Agnes?
Yeah. She's from New York.
Is it like
She's Agnes.
It's one of my friend's grandmas.
Oh.
I was gonna ask, is she old?
And she's from New York. I can just imagine
I've
the
met
conversation.
an Atticus.
Like in To Kill a Mockingbird?
Yeah.
I've met Abbott.
In Costello? Who's on first? Alright, this is number 17 in your book, and I think maybe also number 19 and 21 come with that. If not, they go with this problem and they're assigned for your homework. Not really sure. Don't remember. But this is number 17 out of your textbook.
Do I need my textbook?
No, I was just letting you know.
Okay, that's cool. I was just.
For reference.
Okay.
I'm not saying that the other ones don't come out of the book, but I just happen to know that one's number 17. The Virginia Cooperative Extension reports that the mean weight of yearling Angus steers is 1,152 pounds. Suppose the weights of all such animals can be described by a normal model with a standard deviation of 84 pounds. How many standard deviations from the mean would a steer weighing 1,000 pounds be?
Okay.
It's funny though.
So Z equals what? And as a decimal, that is
You know.
-1.80. How far do you want to go?
2 decimal places.
Okay, 1.81.
So, to conclude, a steer weighing 1,000 pounds would be negative 1.81 standard deviations below the mean. Or I guess I could take off the negative sign because I'm saying it's below the mean. Because it's kind of a double negative if I leave it. Which would be more unusual, a steer weighing 1,000 pounds or one weighing 1,250 pounds?
Well, I guess we gotta do the 1250 first.
Yep, so 1250 minus 1152 divided by 84.
Half this jar.
.17.
So, which one's more unusual?
The 1,000 pounds.
Why?
Because it's greater
more
standard
deviation.
It's farther away from the mean.
Yep. The steer weighing 1,000 pounds is more unusual because it's farther from the mean than the steer weighing 1,250 pounds. Alright, let's see if we can get through this next one.
This one. So literally just not how it works.
Make a compromise with yourself. Like I did myself.
What do you mean
Compromise.
Okay.
Neatness versus
Since this class started, I have gotten 8 emails about picture day on Wednesday. in case anybody wanted to know.
So it's definitely on Wednesday.
Yes. School pictures and sports pictures are on Wednesday. All right.
It's a long one.
It is a long one, but it's less work. All right. The EPA fuel economy estimates for automobile models tested recently predicted a mean of 24.8 miles per gallon and a standard deviation of 6.2 miles per gallon for highway driving. Assume the normal model can be applied. Draw a model for auto fuel economy. Clearly label it, showing what the 68, 95, 99.7 rule predicts about the miles per gallon. So we're going to draw a normal curve. Well, I'm going to write in it. And that's all that's going in this question. So my mean is 24.8. And I'm just going to note down here that this is highway mileage in MPG. Okay, so I don't have to write it on every single one. So my standard deviation is 6.2, so I'm going to add 6.2 on the right. Left, I'm going to subtract 6.2. So I'm going to have 31.0, 37.2, and 43.4. And then the other direction, I'm going to have 18.6. I'm going to have 12.4 and 6.2. So what does the 68, 95, 99.7 rule mean?
One standard deviation, like that area contains 68% of your data.
Yep. So 68% of my data is within one standard deviation of the mean in either direction. What about 95?
I'll let you guys take that one.
Like 95% of your data is in like next, like kind of, or whatever.
Two standard deviations.
Yeah.
All right, Nathan.
3 standard deviations away from
Yep, 99.7
7%.
is within 3 standard deviations. Now, what about that other 0.3%?
We don't care
Outliers.
about it.
It's more than 3 standard deviations away, so it's super unusual, so we really don't care about it.
Well, it's not really important.
So, on what interval would you expect 68% of autos to be found?
One standard deviation,
Which is what?
like
18.6 to
18.6 to 30.
30.
Yeah.
Yeah.
Good job, Josh.
So I said this one's easier than the...
It looks like a lot, but it's really not.
All right, so then what percent of autos should get more than 31 miles per gallon?
31.7. No. 32%. No.
I feel like there has to be something done here.
So how many total percent do I have?
Like 99.7.
No, how many total percent do I have?
60.
In general, how many total percent do I have? 100. Okay, so we start with 100. Now, 31 is at what percentage?
68.
68. So we're going to subtract 68. Okay, so that's taking off this middle chunk, right?
Right.
I still have what's outside of this left, right?
Right.
We following? We're tracking? I have what's outside of one standard deviation away left if I've subtracted off the 68,
Right.
right? I only care about this area over here, correct?
Right.
Okay? So if I only care about this side, what do you think I should do?
Try to get rid of everything to the left of that.
How would I do that?
I don't even know.
I do need to divide.
I remember it.
I only need 1 out of 2 sides.
So we divided by 2.
Divide by 2.
That's really smart.
So that's going to end up being 16%.
It sure is.
Yes. Got
Yay.
Now, you could use the calculator thing and plug in all the numbers and all that, but honestly, this is easier than typing in your calculator at that point. About what % of cars should get between 31 and 37.2 miles per gallon? Any ideas on this one?
8%.
Hold on.
Obviously, you gotta divide it.
Hold on. 27%. That's my guess.
I don't know. What
So 37% is where? Or the 37.2?
Well,
Is that what percent?
What I meant to say was 13.5%.
It's in like
That'll be my guess.
95%.
95. Okay, so this is at the 95 mark. So 95 minus 31 is where?
This is 68%.
Okay, at 68. So we're going to subtract off that. And then much like the other one, I only want this chunk. I only want 31 to 37.2. I don't want 12.4 to 18.6. So I need to
Divide by 2.
divide by 2.
Yeah, I guess.
Yep, 13.5%. And technically, we should be saying on both of those approximately, but it's fine. Describe the gas mileage of the worst 2.5% of all cars.
So now we're going backwards. I'm doing it backwards.
So what is it, like less than like 12.4 miles per gallon?
How did you figure that out?
Because we have the 95 and we want everything to the left of that, so we divide. So we have 100 minus 95 and divide that by 2, and then you get 2.5.
Okay, so I would have,
I'm really catching on to this.
yes, so 95, okay, is, huh?
I'm just a more visual. I can't.
So 95 is this middle chunk, meaning I have how much left on each side?
5%.
I have 5% total left, right? I have 2.5 on each side.
Yes, that's what I meant.
Is that really the bell? So if I have 2.5% on each side, okay, but I want the worst 5%, I need the 5% that's down here. So I basically need to shift my 95% that way. So I'm going to multiply the 2.5 that would be on this side by 2. Okay, so it would be, what's happening? So this would be 2.5% times 2, which is 5%. And that's going to be approximately less than the 12.4 miles per gallon. Because that's where the 95% mark hits. So down here is going to be the worst 5%, basically. We'll do F tomorrow.
You gotta what?
Wait,